Hello, everybody. Can you hear me?
Yep.
This is Lakis Policarpo from the Columbia Water Center. Looks like Professor Lal is running a couple minutes late, but we're going to go ahead and get started. So I just wanted to say welcome to everyone. Welcome to another American Water webinar series. For those of you who haven't joined us before, this is a series that tries to look at the past, present, and future of America's water to help us understand how we can better manage our resources for the future. It's put on by the Columbia Water Center and co-sponsored by CUHASI, the Consortium of Universities Allied for Water Research. The America's Water Initiative is supported by the National Science Foundation. And today we're delighted to be joined by Benjamin L. Preston and Mariya Absar from Oak Ridge National Laboratory to talk about using shared socio-economic pathways to develop regional water futures. So without further ado, I'm going to go ahead and turn it over to our presenters.
Thanks, Lakis. So this is Ben Preston at Oak Ridge, and I'll let Mariya say hello.
Hi, this is Mariya Absar, also from Oak Ridge National Lab.
So thanks to everyone for joining today. We're going to tell you a little bit about some of the work we've been doing here to develop socio-economic scenarios for global change, or particularly climate change research. There we go. And so our slides are up there. So one of the things to bear in mind with the work we're going to talk about is in developing these socioeconomic scenarios, water is certainly one element that we were trying to incorporate and understand and think about how water resources and water resources management might play out going into the future. But that's just one of a broad range of different aspects of the future of the United States at different scales that we were considering, and so that'll become apparent as we move forward. And the way we're going to do this is going to be a bit of a tag team webinar. So I'm going to talk about a bit of the context, the big picture, give background on these things called the shared socioeconomic pathways, and then I'm going to hand off to Mariya to talk more about, dig more into how we developed the storylines and scenarios that we did, and to say more about what they have to say about water specifically. So from a big picture perspective, I mean, what we're really interested in is sort of climate change and the risks of climate change at sort of regional scales. And when we think about something like water resources and water resources management, I think it's fair to say that that's what we would call a complex risk. And so what are characteristics of complex risks? They have multiple causes, some of which might be known and easily anticipated, but others are often unknown, and therefore we're often facing surprises. We're also dealing with situations where uncertainty is high, particularly about the future, and ambiguity is high. And by that I mean it's often very difficult to define what types of responses society should take sort of in response to that particular risk. In other words, there's conflict and disagreement about pathways forward and about how important the risk is in the first place. So as an example, we see all of these issues playing out with the California drought right now, which has been going on for about 4 years. And there's a range of again, multiple causes contributing to that particular crisis. So we're dealing with a region of the United States which is fairly arid. On top of that, we have this multi-year drought, which is sort of exceeding the buffer capacity we have in our reservoirs. Over a longer term time frame, we're dealing with population growth and sort of behaviors embedded in the population about attitudes toward how water should be consumed. For example, large numbers of people watering their green lawns in places like Los Angeles, despite the fact that it's an arid environment and water is a precious commodity. There's other issues around sort of reliance upon large-scale water infrastructure, dams and reservoirs, transfers of water over long distances that create path dependence. And there's issues around institutions, policies that have been in place for multiple decades. And we're seeing a lot of issues around urban and rural divisions and conflict about responsibility for the crisis in the first place and who should manage it. So all this adds up to what we would call a complex risk, which is why there's no easy sort of pathway forward. And you can throw in on top of this climate change. There's a bit of disagreement about whether climate change has triggered or contributed to this particular event, but certainly there's concern that climate change in the future will exacerbate these kinds of issues. Now, that's, the southwestern United States dealing with the drought. We see very similar issues in other parts of the U.S. So in the southeast, which is an area that's generally fairly water-rich, we see similar things, for example, what's known as the tri-state water wars, ongoing political, legal, and management conflicts between the states of Georgia, Alabama, and Florida regarding water resources in that region. So again, population growth, particularly in North Georgia around the Atlanta area, is driving large demands for water. And here the big issue is access of downstream users to water resources. But otherwise, we're seeing similar types of conflicts have been going on for multiple decades. And again, finding a pathway forward in terms of policy and management that satisfies all parties has proven difficult. So in that context, let me advance this one. That's all sort of conflicts we're facing right now in the present. So again, with climate change, we're concerned about how climate change is going to affect water resources in the future and how a changing climate will interact with changing socioeconomic systems. So there's been a number of studies that have been done to try and sort of anticipate where we're going to see future hotspots for water resources scarcity across the United States. So here what we have is one relatively recent study that's fairly well known, looking at U.S. counties, and the figure on the bottom left looks at the anticipated withdrawals of water in the year 2050. So the dark browns are areas of higher water use. They tend to be associated with urban areas or irrigated land areas. And the figures on the right represent a risk index for water resources scarcity. The top right figure shows risks accounting for projected changes in climate and particularly rainfall. And the bottom right figure shows risks if we ignore climate change and just look at sort of the human-driven demand. And what we see is climate change is obviously exacerbating the water resources scarcity quite significantly, particularly in the southern United States and Southwest. Now, when we do these kinds of studies, they're often based on sort of business as usual projections or forecasts of demand. And this is basically best guess of what population is going to be, how much water is going to be used for energy, and how much water is going to be used for irrigation. But particularly over these sort of multi-decadal timescales, all of these factors are inherently uncertain, and the uncertainty is pretty much irreducible for many of these driving forces. So a lot of this will depend upon things like policy changes, management changes, where people are going to be, how the economy is going to grow, and those can often be sort of stochastic processes, particularly at the local level. So one of the things we're interested in is exploring how uncertainties in human dynamics and human systems in particular contribute to sort of ameliorating or exacerbating these risks at different scales. So that leads us to using socioeconomic scenarios. And so why do we want to use socioeconomic scenarios? Because across the work that we do and thinking about future consequences of climate change, the dynamics of human systems are really important to understanding and projecting not only the consequences, but also how society can respond. So qualitative storylines about socioeconomic systems or qualitative scenarios, or to some extent quantitative scenarios, are one of the more common ways in global change research that we sort of represent human systems and how they change over time. And the shared socioeconomic pathways, which I'm going to say more about in a minute, are the sort of new opportunity, the sort of current latest set of socioeconomic scenarios that have emerged just to try and have a coherent set of socioeconomic futures that can be used across different research communities in global change or climate change to think about not just how we, not think about not just the consequences of climate change, but how we can adapt and or mitigate future greenhouse gas emissions. So the objectives for our work are really to explore how we can use these shared socioeconomic pathways, or SSPs, in impact adaptation and vulnerability research, and that includes modeling of impacts or broader assessments like the U.S. National Assessment or assessments conducted by the Intergovernmental Panel on Climate Change. Sort of looking at sort of the opportunities as well as challenges with working with this scenario framework, and we'll get into some potential applications of using these scenarios and some impact modeling. So that's sort of context about what we're attempting to do in our work. We've been pursuing this under the auspices of a research project funded by the Department of Energy Office of Science. It's a development of a regional integrated assessment modeling framework. It's focused on the region on the map there, so effectively the southeast United States, from Texas over to the Atlantic coast of the Carolinas. And as with any integrated assessment modeling project, it's trying to incorporate and model not only changes in biophysical systems, what's happening with the climate and water resources and land use and land cover, but also some of the socioeconomic systems in terms of population, demography, the economic performance and development of different sectors. So that's the region as sort of we defined it for this particular work. And for our purposes, and for this project, there are some key sectors that are really of interest, and that's what's going to happen with energy, both supply and demand, issues around land use and sort of agricultural activity, because that's an important climate-sensitive resource, and then also what's happening with water resources, because you need water for agriculture and energy, as well as to sustain a growing population. So that's just a little bit about the sort of region that we're working in. So I want to say a bit more about the shared socioeconomic pathways. So for those of you who, and this is particularly for those of you who aren't necessarily familiar with how scenarios are currently being used in climate change research, in particular, climate change research is often very dependent upon scenarios because it's looking into the future. And again, that future is inherently uncertain. And so a number of years ago, a quote-unquote new scenario process was started to support climate change research, and this is an international effort. And it was called a parallel process because it was comprised of two sort of separate tracks. So one track, one activity focused on developing what are referred to as representative concentration pathways, or RCPs. And these are essentially the greenhouse gas scenarios, greenhouse gas concentrations in the atmosphere, which are then used in climate models, Earth system models to project how the climate might change in the future. In developing those, however, there weren't explicit assumptions about the socioeconomic conditions that are giving rise to those different concentration pathways, The argument being that you can achieve a particular concentration in the atmosphere through a wide variety of socioeconomic development pathways. And so to some extent, these are independent, although not entirely. And so the RCPs were developed a number of years ago. They were used in the climate model intercomparison 5, or otherwise effectively known as the IPCC's fifth assessment report. So all of those climate projections are based upon the RCP forcing scenarios. The shared socioeconomic pathways are the other process, and they represent storylines about how effectively global society might evolve going into the future. So this is describing socioeconomic conditions around the world in future decades and their various trajectories. Those have only more recently emerged, so the main publication describing the shared socioeconomic pathways, qualitative narratives, just emerged earlier this year. And so this is a more active and an emergent area of research. And so the challenge now is to put these different activities back together. So to integrate the RCPs and what they project about future climate with the SSPs and what they have to say about future population, economic conditions, vulnerability, and adaptive capacity. And so that's where we are now with research. So we have a lot of work that needs to be done moving forward in integrating these two different scenario activities to inform how climate change, mitigation, and adaptation will evolve going into the future. So I'm not going to say much more about the RCPs, but to elaborate on the SSPs and what these things really are, effectively they are, as described in one recent paper, they're reference pathways describing plausible alternative trends in the evolution of society and ecosystems over a century time scale. These are long-term socioeconomic trajectories, and the key framing for these is based upon two axes. So in this figure across the x-axis across the bottom represents increasing socioeconomic challenges for adaptation, and the y-axis going up to the top on the left are increasing challenges for mitigation. And so the idea when these were first being developed was that these are two key factors that affect the rates of future climate change and the consequences of climate change based upon the extent to which society will be able to reduce its emissions and or adapt to the effects of a changing climate. So within that space, there are 5 qualitative narratives or storylines that have been developed. And so in the bottom left, you have SSP1, which is called sort of the sustainability pathway, which is characterized by low challenges to adaptation and low challenges to mitigation. So as you can imagine, there's a shift toward more sustainable use of natural resources, investments in energy efficient technologies, modest rates of population growth, more equitable economic development. So this is sort of low impact or low footprint, ecological footprint development. In the top left, you have sort of the exact opposite of SSP5, which is the fossil fuel driven development. So this is characterized by sort of rapid population growth, rapid economic growth, very much using technology to solve challenges that appear for society. You end up with relatively low challenges for adaptation because it's a wealthier, technologically savvy world. But you have much greater challenges for mitigation because you're really continuing to rely upon fossil fuel energy sources to drive that development. The top right, SSP3, regional rivalry, is really about sort of difficult geopolitics around the world, So lots of competitions between nations, between continents, things like lots of barriers to trade, which makes it sort of an anti-globalization movement, and that creates both challenges for adaptation and mitigation because you don't get cooperation and you get these sort of regional inequalities. SSP4 in the bottom right assumes that there's a small elite that controls resources around the world. Those elites generally control the future of energy, and therefore if they chose to, they could reduce future emissions. But because power is concentrated with a small number of people and organizations, there's a lot of inequality, and therefore the masses have difficulty adapting because they don't necessarily have access to the same levels of resources. And then SSP2 is a sort of middle of the road that sort of balances out across those different trajectories, so it's kind of a muddling through type of scenario. So those are the sort of the 5 SSPs. In our work, we started out with all 5 of those, but we eventually excluded SSP4 from future consideration. We can address that point in questions and answers. It's a bit of a long-winded explanation, but we largely worked with the other 4 SSPs in the work that we've done. So the challenge, and this is probably the most important part about this, the big challenge with using the SSPs is as they are defined, they are qualitative storylines at the global level. Okay? So if you're interested in what are the impacts of climate change for the southeastern United States, the SSPs as they've been produced don't necessarily provide a lot of information. Okay? So in order to make these things useful to a larger audience, particularly those of us who think about climate impacts at a local or regional level, you have to figure out how to bridge the sort of scale divide between these global descriptions of what's happening with socioeconomic systems and what's happening at the local level. So there's a couple of different ways of going about this. This is not a unique problem to the SSPs. So one way of doing this, which is the way we pursued, is to use the global SSPs as sort of a starting point. So they represent initial boundary conditions, and you build, I guess, downwards from those and think about how those global scenarios might play out at the national level or the regional level. The other thing you can do is work from the other direction. So start at the local level and think about what kind of socioeconomic features are relevant to your particular context or your community, and then try and match those back to these global level descriptors. So I've seen both of these approaches being used. They both have their strengths and weaknesses, which is why this is sort of an ongoing research activity and why we're interested in different groups trying to work with these SSPs to figure out what works under different contexts. But for our purposes, and going from the top down, starting with the global SSPs, we used a framework called the Factor Actor Sector Futures Framework. This has been around for 15 plus years. There's a number of papers that have been published using this approach, and it frames future socioeconomic developments around these 3 components of a factor, actor, and sector. So a factor is a aspect of a social and natural system. So you can think of this like a traditional socioeconomic driver: population, GDP, technological change. Those are the factors. Actors are any individuals or organizations that are sort of important in driving change or inhibiting change. And the sector is a subcomponent of natural social systems. You can think of these as traditional economic sectors, public health, water resources management, agriculture, forestry, defense, telecommunications, so on and so forth. And so for our purposes, these different factors, actors, and sectors represent quote-unquote storyline elements as we describe them. So every factor, every actor, every sector is a component of a socioeconomic system. that you would like to be able to define for each of these SSPs and at different scales. So this table, so in approaching this, and Mariya is going to say more about how we move from the global to the local, but just to give you an idea of what factors, actors, and sectors, or what storyline elements we accounted for, our starting point was to brainstorm about which factors, actors, and sectors are relevant to the work that we're doing, and we came up with this list that was quite independent of the SSPs and the information contained within them. So, so on the left-hand side, we have a range of factors, a range of actors, a range of sectors that we considered, and then to the right, the sort of dots or dashes represent whether or not that particular factor, actor, and sector was represented or addressed at each scale in our analysis. So we have a global scale, a national scale, and a subnational scale, which represents the Southeast United States. And so wherever you have a sort of a dot, we developed a very brief qualitative narrative description of what's happening with that particular element for each of the SSPs. You can take all of those individual elements and synthesize them like this figure. So what we've done here is for all of those factors, actors, and sectors, for all of the SSPs at the global, national, and subnational scale, we've indicated the trajectory for the factor. So for example, is population going up in this scenario with this scale? Is it going down? Is the economy growing rapidly or slowly? Is land use changing rapidly or slowly? So we have those trajectories for all of our factors, and then what we also have is an indication of to what extent what's happening with a particular element is either creating challenges for adaptation or creating opportunities for adaptation. So rapid economic growth, for example, can create opportunities for adaptation for human systems, but it might create challenges for adaptation in ecological systems by degrading natural resources and natural capital. So that's just a sort of snapshot of the different trajectories. And the other thing to notice is that we don't necessarily address every particular sector at every scale. So the SSPs often lack information about what's happening with a particular sector. They don't say a lot about what's happening with agriculture at the global scale. They don't say anything really about what's happening with, telecommunications at the global scale. For our purposes at the national level, we try to create a complete picture, and then at the regional level, we focused on a few small sectors, and Mariya is going to say more about that. So as you can see from this, water is just one, again, of a number of elements that we're considering in these. And in addition to having this sort of breakdown of individual elements, we can also aggregate all of these things up into a new storyline. So we have a set of storylines at the subnational level, particularly focused on energy, water, and agriculture that capture sort of all of these developments across all of the different SSPs. So I think with that, I'm going to hand it over to Mariya, who's going to say more about a little bit more about methods in terms of how we move and develop content at global versus national versus regional scale, and say more about what our work has to say about water in particular.
Thank you, Ben. So I'll begin by talking a little bit about the current trends around off-stream freshwater withdrawals in the U.S., particularly from surface and groundwater. And as you can see in the pie chart on the right, most of the withdrawals are primarily for thermoelectric cooling, irrigation, and domestic water use, which combined make 90% of water withdrawals. Within the energy sector, a lot of water is taken out for cooling purposes. Traditionally, they used once-through cooling, which uses water once and then dumps it back into the water body. But recently, recirculating cooling systems are being adopted by the new power plants that are coming up. So that's leading to a lot of water efficiencies in the energy sector. In the irrigation sector, a lot of the western states are still practicing flood irrigation as compared to sprinkler irrigation and drip irrigation, which is more prevalent in the eastern United States. So water withdrawals for flood irrigation is exacerbating drier conditions in those states. However, having said that, even though per acre irrigation is relatively constant, there is a marked increase in the yields of major crops in the country, which suggests that there is increased water efficiencies in agriculture as well. And similarly, for municipal water usage, there have been a lot of water conservation programs that have also led to decrease in per capita withdrawals around water. So this is just to show that why we're focusing on energy, agriculture, and water use within these two large sectors, because 90% of the water is going in these sectors. Next, I will sort of take you through the development of nested storylines, as Ben mentioned, but with a particular focus around the water storyline. So we started out by looking at the storyline elements and identifying the storyline elements, as Ben had shown the factor, actor, sector list for our particular interest, and how we develop we identify these storyline elements across the three scales, and that was largely based on literature review. Particularly for the water sector, the elements were defined based on common inclusion in global assessments such as the IPCC, particularly the Working Groups 2 and 3 reports, common outputs from integrated assessment models, and just because they had been identified as having significant geopolitical implications, so those elements were included in our water storylines. Next, we took the global qualitative storylines, which largely have information for developed and developing countries, and we mapped those narratives to these identified storyline elements. Now, keep in mind that those storylines do not have information around all the storyline elements that we've identified, but what we did was to strip the narrative and extract relevant information that we had for each of our storyline elements, and then documented those in a database so that we knew which ones were included and which ones were not included, as you'd seen in the earlier tables that were shown to you. But the idea was to keep the global SSPs intact and not to touch them, just use them as boundary conditions. Next, we moved on to developing the national storylines. As we moved to the national scale, some of the storyline elements were either dropped or had to be developed from scratch because they were not present in the global storylines. A couple of challenges that we faced were that the global SSP narratives lack detailed information at the national scale, which is kind of evident from the fact that they're global, so they have information about developed and developing countries alike, so they're very, very, very generic. So we had to develop detailed information with regard to U.S. on the national scale. And secondly, storyline elements, some of them are not articulated in the global SSPs, just like agriculture was pointed out earlier, or defense, or telecommunications. So we had to develop those from scratch for the U.S. because those are relevant sectors or factors that need to be developed more holistically. And to do that, we looked at peer-reviewed and gray literature and current scenarios that have been published around these around these sectors and factors to develop our storylines. But when we were developing these storylines, we also try to maintain tight coupling with the global SSP so that there was internal consistency, and also try to keep a focus with keeping challenges for adaptation in mind. We also made an effort to maintain horizontal consistency amongst the elements that evolve in tandem. For instance, population and economic development do directly affect how much water is being used or demanded or supplied, so they had to be like internal consistency within each SSP as well. For our sub-national storylines, we basically use the same elements as we did for the national scale, but we focused only on 3 sectors at this scale: water, energy, and agriculture, because those are the most important for our study and most relevant for our region. So how we went about doing that was that we looked at each of the 10 states in this region and looked at how the different factors, actors, and sectors have evolved and are going to evolve within these states, and then we combined that information for the regional scale so that we could have narratives around that region. And again, we maintained vertical and horizontal consistency so that we have alignment with the global SSPs and national SSPs, and also within each SSP across the board with other factors and actors and sectors. Here is a list of the sources that we used to develop these storylines. On the global scale, you can see a couple of papers that were published around the global SSP narrative. That's what we used. And then for the national scale, most of these studies are published scenarios or trajectories or projections for various factors and sectors. So those were very, very important, and we extracted those that were most relevant to the SSPs that we were considering. And a lot of these sources also had extensions to sectoral level, the subnational level. So those are very important, and that's what we used to develop our storylines. Here's a schematic that gives you an idea of what the actual storylines that we keep talking about look like. So on the global scale, you can see that the narrative around water. So here, this schematic only looks at SSP1 and SSP5 as a comparison. So you can see at the global scale, the storyline is succinct and does not give you a whole lot of information around that sector, and that's by design. And also because they have to be generic enough to be applied to all developed and developing countries on the global scale. But when you move to the national scale, we need to have more detailed information on the water sector, particularly that's the relevance to the national scale. And then moving on to the subnational scale, you see that the storylines have more detail than national and global scale, and they possess information on sources of water supply, competing demand for water by various sectors, cost and accessibility of water, and investments in technology and infrastructure. So here's our storylines, and how do we use these storylines within an impacts or adaptation study? So I'm going to demonstrate how we have used socioeconomic storylines within a framework or within a modeling framework that is available or has been developed by Oak Ridge National Lab. So we started out with this capability. We used a point-based crop simulation model called DSAT. It simulates crop production over a large time period using daily temperature, rainfall, solar radiation, and various management practices. So the idea was to use a biophysical modeling framework and use various global climate models to provide data on temperature, rainfall, solar radiation, and use management practices that we felt were relevant to the baseline that we're using, and to see what the future looks like, and to cover the climate uncertainties with regard to crop production in this region. So this capability basically uses DSAT model and runs it in a high-performance computing environment using multiple processors to simulate corn production in one 1,009 counties of southeastern U.S. These simulations use 3 global climate models of the GFDL family for the highest greenhouse gas emissions scenario, which is the RCP 8.5, so which means that it has it assumes that the future greenhouse gas emissions are going to be very high. And the simulated time period was 40 years in the baseline from 1965 to 2005, and 40 years in the future from 2010 to 2050. So it was more of a near-term sort of simulation. So like basically it's looking at the climate uncertainty and the climate impact on corn production in this region. So just to sort of understand how corn production would vary over time, these graphs show a difference between the future period and the baseline period in regions that would experience higher growth in corn versus lower growth in corn. But to demonstrate how we can use the socioeconomic pathways to help us figure out what the socioeconomic makeup would be in the next 50 years or so, we would have to use them to come up with or to quantify modeling parameters such as management practices that go into running this simulation. So for our initial simulation, we used basically rain-fed agriculture, so no irrigation was used. We also used planting dates that were recommended by USDA, and in addition, we used high inputs of fertilizer so that we can see how if there was no constraint from the fertilizer side, how would rain-fed agriculture fare in this region. So those management practices can and should be developed based on the SSP or the regional SSP you're considering, and then using those qualitative storylines to develop quantitative parameters within a modeling framework like DSAT. So essentially, oops, I think there's a little part of our slide is missing.
Got a figure drop out. That's okay. We'll manage.
Okay, so there is, okay, maybe I should just say what's missing in the middle of the slide. So there is essentially what this slide is showing is that so the management practices that go into running a crop growing simulation, you can have a whole suite of management options. You can have a whole suite of how much irrigation goes into it, or how much fertilizer can be applied, or how much or how the planting days can be shifted to accommodate based on different temperatures and precipitation, or shifting seasonal changes within a given year. So you could go from low intensity management practices all the way to high intensity management practices. So for each SSB, you would have a whole suite of information around how much irrigation, how much fertilizer, if there's going to be tillage or no tillage in the agriculture, or what sort of planting dates would be recommended to go with a given socioeconomic pathway for that region. Other issues or factors that would also go in, which are not considered in the crop simulation model we're using, but we would like to identify that parameters such as biotechnology innovation, which translates to specific cultivars that are selected as our input, would also be very highly consistent with the socioeconomic pathway that we're using. And also issues like market mechanism or irrigation schemes, or how irrigation is actually conducted on a given location, would also be consistent with a given socioeconomic pathway. So this is just to show how the climate uncertainty and the socioeconomic uncertainty within a modeling framework comes together to help us come up with an adaptation portfolio. So on the left side, we have a list of regional SSPs, and for the sake of simplicity, I only picked those management practices that were relevant to water, but there would be a whole suite of input options for each SSP that could be translated into input parameters for DSAT. And then on the right-hand side, you see that we have used multiple global climate models as a multi-model ensemble to see how various model outputs for temperature, precipitation, solar radiation would also cover and come together and give us help us address the socio-ecological uncertainty space. So when you have all the different socioeconomic inputs and all the global climate inputs coming together, you can then make a better decision about what's the best adaptation portfolio for your region, and we've marked that hypothetically as the X adaptation portfolio, just to give you an idea. Like I said, there was not enough space to show how those socioeconomic pathways can be translated into management practices. I've actually listed each one of them here as an example of how those management practices change for a given SSP, and you can they can be very easily aligned with what's going on or what makes up the socioeconomic pathway within an SSP. Now I'll hand over to Ben to summarize the key points of this presentation.
Yeah, well, thanks, Mariya. So so we've been working on this, what, two or three years now. So it's difficult to breeze through it in 45 minutes or so. But that's sort of the high level of what we've been up to. And so just to give you some takeaway messages. So the SSPs, which you've heard a bit about now, can be used to develop future pathways for water resources, but as well as other sectors. The important thing here is that we're not just looking at water resources in isolation or the other sector in isolation, but trying to think about water as part of a larger socio-ecological system. So these things are all going to change in the future in sort of interdependent ways. And therefore, in doing these sort of scenarios and modeling activities, we're trying to be a bit comprehensive in thinking about how society evolves in the future. The big issue for us, where there's a lot of experimentation going on right now, not just amongst ourselves, but among various groups around the world, is how to apply these SSPs at this sort of regional scale or community level across a range of different scenario processes. So we've taken a very sort of top-down, quote-unquote objective approach driven by sort of precedent and peer-reviewed literature, but other people are using these things in a very participatory way. So working with communities and community representatives in workshops to develop their own sets of sort of socioeconomic futures, and then only after that are they asking, how do these link back up to the SSPs? But the idea is there's this opportunity for multiple groups at multiple scales doing different types of research to some way link up to this SSP framework, so that we will have in coming years a diversity of research results and outputs that have at least some high level, some consistency with respect to the assumptions that are being made or the worlds that are being assumed, which might help enhance the ability to make comparisons across different time frames, different spatial scales, different sectors. The big challenge for us is how you take a sort of qualitative storyline and turn it into a quantitative model parameter. This is, something, you don't have to do this. There's lots of people doing interesting things with purely qualitative scenarios. But if you're trying to do quantitative modeling, at some point you have to do that translation step. And that remains, to some extent, a subjective process based upon quote-unquote expert judgment. But that does raise issues for, how consistency. Can you do that in a way that is consistent and reproducible? And I know at least a couple of people who are working on how you can do that evaluation of consistency to make sure you're not introducing bias or sort of erroneous, inconsistent assumptions into your scenario process. And then lastly, and going back to sort of water resources, some of the key uncertainties or dimensions that come out of the work that we've done really relate to sort of how water is governed under sort of alternative supply-demand dynamics. And by that, what I mean is, some of the regional SSPs emphasize very much focus on demand management. So a sustainability SSP really focuses on demand management, water use efficiency, whereas SSP 5, which is really sort of go for fossil fuel development, really just tries to address the supply issue. So, building reservoirs, interbasin transfers, big infrastructure solutions to capturing water to address the demand. Similarly, very different perspectives with respect to sort of the culture of consumption around water, and also I think a big factor is the extent to which sort of market mechanisms like privatizing or commoditizing water in order to drive water to its, quote unquote, most profitable use, most economically efficient use, use of the highest utility. So that's a strong feature of some of these, high growth futures, whereas sustainability, because it's more focused on demand management and equality, is sort of less focused on the sort of privatization of water as a commodity and more as a common good. So I think we'll stop there, and just to point out that this work was published earlier this year in Global Environmental Change. So you can look up, and there's more information in there than you probably want to know about methods, and more complete descriptions of the storyline elements and the eventual sort of regional storylines that emerge for the energy, water, sort of land sectors. So we'll cut it off there, and hopefully we've got some time for questions. Thanks. And I'm assuming there's lots of applause going on in the background, but.
Absolutely. Yeah. So thanks, Ben and Mariya. People who are online, please ask your questions by typing them in. This is Upmanu Lal. My apologies for getting here late. I got held up in our departmental faculty meeting where matters of utmost importance, life and death, were apparently being discussed, and they didn't want me to vanish. But I think I got most of it. So I'll lead off with a question for you guys. This was very interesting. The leading question that I have, which relates to what we are trying to do, in a way, is have you guys looked at estimating water consumption or demand or energy consumption or demand in the past as a function of climate and as a function of prices and other factors? Or do you have a recommendation for work that you have seen that you think was really good in that regard and was down to county or state levels?
Yeah, so that's a good question. We haven't done that so far. One of the things that moving forward, so we sort of the work we've been doing that funded this for DOE, we have a sort of a new project moving forward that really focuses more on energy water nexus. And
Right.
as part of that, we're interested in developing sort of we'll call it sort of energy water futures that look at projections of energy demands and water demands as a function of agriculture and energy sectors and population. That would be at these very sort of localized scales. I'm thinking sub-county level. That's very much prognostic information. What I've seen in terms of looking at historical developments, all I've really seen are people mapping out USGS estimates at the county level of what's been used, without a lot of understanding of what the relationships are. So as you're saying, how does water use historically in a particular county relate to other types of socioeconomic conditions or economic structures within that particular county. So it's just an observation or estimate of use without getting into sort of causal factors, or at least correlated factors that might explain that. So that's interesting work, and glad you're sort of interested in pursuing that. So the work that we talk about here, so Roy et al., a number of papers, all looking at future water demands from different sectors, or trying to look at them in aggregate, is the closest I've seen to something like that. But again, it's more water accounting than really explaining the dynamics.
I feel like a lot of these studies that are done at a very fine local scale tend to be done with a more participatory bottom-up approach, because that kind of takes into account a lot of these factors that are playing a part on a very like a lot of studies who work on that level tend to get hold of all the stakeholders around a given um, sector, or just a combination of factors and actors and sectors coming together and developing a bottom-up approach to understand what's going on at that scale.
Yeah, and just following up on that, I think one of the challenges we face in trying to make any of these sort of projections or scenarios of the future is trying to understand why people do what they do, and it's without, and that sort of on-the-ground knowledge, and trying to understand why we see the trends that we see in different locations, and probably, those are being driven by a diversity of factors depending upon where you are, not just, that varies depending on what country you're in, but probably varies within the United States depending on what county you're in. So some of that sort of on-the-ground work to understand what drives behavior, particularly around behaviors of consumption, how local policies, technological availability, regulatory barriers sort of inhibit or constrain different types of activity is sort of useful. And it's hard to get at that, sitting in an office just trying to make these sort of large-scale national projections.
Okay, thanks. I mean, I'm not seeing any other questions from people, so I think I'll just pipe in with a comment here.
Yeah,
What
sure.
we are trying to do is to essentially take a statistical approach to understanding past variations in consumption, but the challenge that we run into is that the demographic factors at the city county level, I think we can get that data, but we have not been able to get data at that scale for water or energy consumption, aggregate or disaggregated. And that seems to be the primary challenge in building a formal approach, is really access to data which we know is getting collected but is not getting shared.
Yeah. So yeah, and that's going to be a tough one, right? Because I think probably where you might be able to get that, once we have smart meters for every household for energy and water, some of that data will be available, but that's a ways down the road, and it doesn't help you looking backwards. So even if you went utility to utility around the country, you'd probably still have trouble getting a high degree of granularity around the information. All you could really do is sample based upon the coverage of the utility. So I think really if you really want sort of some uniform coverage, you're going to have to model historical dynamics, and then try and ground truth that model with bits and pieces of data that you can get where available. But yeah, it's funny how in trying to understand the future, your starting point is to understand what's happened in the past, and it turns out that in and of itself is really, really difficult, even though, we've experienced the past already, but we just didn't collect the data in a way that, makes it able to sort of look back with a high degree of accuracy. So for us, when we think about how we develop these sort of, spatial energy water futures under different scenarios, one starting point for that might actually be trying to do that from a historical perspective and start there and see to what extent it's possible to ground truth, a historical sort of model or reanalysis before thinking about how to project that into the future. But yeah, I don't.
Ben, there is actually a
It's a tough
question
one.
typed in by Larif. I don't know if you can read it there.
Yep, we see it.
Uh, he says, is it possible to have an overall modeling or simulation framework to look at all the connections at global or regional scale meaningful? If you can do this, can these be related to the type of projections such as in DSAT?
Yeah. So great question. I mean that's sort of the that's sort of the direction that people want to head in, right? So the current state of integrated assessment modeling, where we're working with Pacific Northwest National Lab and the GCAM framework. I mean, what they've been doing is trying to push that model, which started out years and years ago, dividing the world into sort of these continental scale groupings. They've been pushing it to finer and finer resolution. So now it is a global model, but it models dynamics for and the other thing that they're doing is calling finer scale models to that. So for example, there's a paper Allison Thompson and others from P&L authored a couple of years ago where they used a point-based crop model, much like DSAT. It's called EPIC. But they used that model to basically project changes in agricultural yields with a high degree of granularity, but then they aggregate that information up into GCAM, or one of they're basically into an integrated assessment model. So you're getting some of the fine scale local processes that are being modeled, but then that information is being rolled up, so you get this sort of regional and global scale interactions as well. And so that's the kind of thing that the Department of Energy is interested in doing now, which is how do you build these sort of modular modeling frameworks to allow you to have some core sort of global model running in the background, but you have other models that you can couple to it that allow you to drill in and look at effects and impacts at more localized scales. So it's possible, but it is, it's challenging, not just from a conceptual standpoint, but also just from a software or hardware standpoint.
Okay, thanks very much, Ben and Maria. Looks like there are no other questions, and we are beyond our time. So thanks very much, and I would love to follow up with you to discuss, further on this.
Sure, no, happy to.
You're welcome.
We'd like to hear more about what you're up to over there.
Right. Yeah, no, we can set up a call and do that.
Okay.
Definitely.
Okay,
Thank you.
thanks so much.
Thanks, Albano. Thanks, everyone else.
Thank you, everybody.